A woman wakes up one morning feeling fine. No pain, no symptom, nothing unusual. 6 months later, she's told she has weeks to live. This is pancreatic cancer, the deadliest common cancer on Earth. For decades, doctors have thrown everything at it. Surgery, chemotherapy, radiation. Nothing works. The 5-year survival rate, around 12%. Most patients don't make it past a year. But in 2023, something changed. Scientists tested a vaccine, not to prevent the disease, to cure it. And in a small group of patients who should have been dying, half of them were still alive 3 years later, with no sign of the cancer returning. So what is this vaccine? How does it work? And could this actually be the breakthrough we've been waiting for? Let's break it down. Pancreatic cancer is terrifying for one simple reason. You don't know you have it until it's too late. The pancreas is a small organ tucked deep in your abdomen behind your stomach. It does 2 critical jobs. First, it makes enzymes that help you digest food. Second, it produces insulin, the hormone that controls your blood sugar. It's about 6 inches long, shaped kind of like a flat fish. And when cancer develops there, it's almost invisible. Most cancers give you warning signs early. A lump you can feel, pain that doesn't go away, changes in your body you can track. But pancreatic cancer, it sits quietly in one of the most hidden places in your body. By the time you feel anything, maybe some back pain, some weight loss, a little yellowing of the skin, the cancer has usually already spread to other organs. At that point, surgery often can't help. Chemotherapy might buy you a few months, but the odds are brutal. Steve Jobs had it. He lasted 8 years, which is extraordinarily rare. Ruth Bader Ginsburg had it. Jeopardy host Alex Trebek had it. Patrick Swayze, Aretha Franklin, all gone within a year or 2 of diagnosis.
It is the single deadliest form of cancer, one so many familiar names have faced in recent years. Patrick Swayze, Randy Pausch, Steve Jobs, all felled by pancreatic cancer. So what are the warning signs?
It's not that doctors don't understand the cancer. It's that the cancer is designed to hide and spread. So for years, scientists asked the same question. Why can't the immune system stop it? Your immune system is one of the most powerful defense networks in nature. Every day, cells in your body mutate. Some of those mutations could become cancer. But most of the time, your immune system catches them. Special cells called T cells patrol your body, looking for anything that doesn't belong. When they find a rogue cell, they destroy it before it can multiply. This happens constantly. You're probably preventing cancer right now without even knowing it. But here's the strange part. Pancreatic cancer doesn't just evade the immune system. It tricks it. The tumor builds a shield. It surrounds itself with a thick, fibrous barrier made of proteins and dead cells. Scientists call this the tumor microenvironment. Think of it like a fortress. The cancer hides inside, and the T cells can't get through. Even if they could, the tumor releases chemicals that essentially turn off the immune response. It's not just hiding, it's actively defending itself. So even when doctors remove the tumor with surgery, microscopic cancer cells are usually already floating around in the bloodstream. Within months, they grow back. The immune system never gets a chance to fight. That's why survival rates are so low. That's why chemotherapy barely makes a dent. But what if you could train the immune system to recognize the cancer before it rebuilds? What if you could teach T cells exactly what to look for so they could hunt down every last hiding cell? That's exactly what this vaccine does. Let me be clear. This is not a prevention vaccine like the ones for measles or polio. You don't take it to avoid getting cancer. You take it after you've already been diagnosed and treated. It's called a therapeutic vaccine, and the idea is surprisingly simple. Here's how it works. When surgeons remove a pancreatic tumor, they send a sample to a lab. Scientists sequence the tumor's DNA and compare it to the patient's normal cells. What they're looking for are mutations, tiny genetic errors that make the cancer different from healthy tissue. Every tumor is unique. The mutations in your pancreatic cancer are not the same as someone else's. So the vaccine has to be custom-built for you. Once they identify the mutations, they create snippets of protein that match those errors. These are called neoantigens. They're like wanted posters for the immune system. The vaccine delivers these neoantigens into your body, along with a chemical booster that gets your immune system's attention. Your T cells see the neoantigens and learn, this is the enemy. They memorize the pattern, and then they go hunting. If any cancer cells are still hiding in your liver, your lungs, your lymph nodes, the T cells find them. Because now they know exactly what they're looking for. The vaccine doesn't kill the cancer directly. It teaches your body to do it. The trial that made headlines involved 18 patients. All of them had surgery to remove their tumors. All of them received chemotherapy. And then half of them got the personalized vaccine. Normally, after surgery and chemo, about 70% of pancreatic cancer patients see their cancer come back within a year and a half. It's almost guaranteed. But in the vaccinated group, 50% showed no recurrence after 3 years. That's not a cure, but it's the longest remission scientists have ever seen in a controlled trial for this disease. Even more remarkable, the patients whose immune systems responded strongest to the vaccine were the ones who stayed cancer-free the longest. Their T cells were still active, still hunting years later. One patient's cancer had already started to return before the vaccine. After the shots, it vanished completely. Now, you might be thinking, okay, that's amazing, but it's only 18 people. What about everyone else? And you're right. This is early, very early. The challenge with this vaccine isn't whether it works. The challenge is scale. Creating a personalized vaccine takes time, and pancreatic cancer doesn't wait. But here's where things get interesting. Scientists are working on ways to speed up the process. New AI tools can analyze tumor DNA faster than ever before. Researchers are testing similar vaccines for melanoma, lung cancer, colon cancer. This isn't science fiction. It's happening right now. For decades, cancer treatment has been about poison. This vaccine is different. It's not about destroying the cancer from the outside. It's about waking up the defense system you already have. Your immune system is stunningly powerful. It just needs the right information. Pancreatic cancer has been hiding the same way. This vaccine pulls back the curtain. And if it works for pancreatic cancer, one of the hardest cancers to treat, it could work for almost anything. But here's what's undeniable. The patients who got this vaccine and stayed cancer-free, they were supposed to be dead by now. And they're not. Right now, larger trials are underway. The goal is simple: make the cancer visible, make it vulnerable, and let the immune system finish the job. And maybe, just maybe, we'll stop thinking of this disease as a death sentence. But here's the part that keeps me up at night. If we can train the immune system to hunt cancer cells that are genetically unique to each patient, what else could we train it to do? Pancreatic cancer might just be the beginning. So if you or someone you know has been touched by this disease, don't lose hope. The fight isn't over. And for the first time in decades, we might actually be winning. If this made you think, share it with someone who needs to hear it. We uncover mysteries like this every week here at Discovery Hidden Mystery, where the impossible becomes explainable. Hit subscribe and turn on notifications so you never miss the next breakthrough that could change everything we know about life, survival, and the human body. The next mystery is already waiting.